One of the things we learn about in equilibrium, or we're going to learn about right now, is something called Q. I'm going to talk about Q. And a good way to think about Q is kind of like a good example would be like, let's say you want to go to SeaWorld, right? So I have a map of Florida over here. Slide this over. You look right here, this is the state of Florida. Let's say Boca's right here. Let's say this is Boca. Let's say you were going to take a trip to Orlando, which is right there in Florida, and we're in Boca, and you were going to drive there. It's basically Q is a way, I want you to think of Q as telling where you are, where a reaction is really. Lets you know where a reaction is in equilibrium calculations and which way we have to go. So let's say you want to go to SeaWorld, and let's say SeaWorld is exactly 190 miles away from Boca. 190 miles away from Boca. You want to go from here to there. That would be like our K in our problems. Equilibrium is an exact spot. And it's the exact place. And basically Q, the reason we calculate Q is it lets us know where we are in relation to equilibrium, because all reactions aren't at equilibrium. Sometimes they're before, sometimes they're after, and they have to get there. So here's the example. You hop in a car, you drive for an hour. If you drive for an hour, you drive 75 miles. At that point, you're about right here. You are not in Orlando yet, or you're not in SeaWorld yet, because you're not at 190 miles. You're short. You're at 75 miles. You're not quite there. So you have to keep going. You have to keep driving forward to get to Orlando. So you drive. That's after 1 hour. You're still not in SeaWorld. So then the second hour, you drive another 75 miles. I've gone now. That's my second hour. I've driven for 2 hours. I'm somewhere like right there. And at that point, I've covered 150 miles. And notice that's what it says on my trip meter is 150. But yet 190 miles away is SeaWorld, so I know I'm not there yet. I have to keep going forward. So it's letting me know that I have to go forward, or the reaction has to go forward. Well, let's say I drive another hour and I drive another 75 miles. At that point, I've driven 225 miles. Now at that point, I'm actually past SeaWorld. So the only way I can get to SeaWorld, or 190, which was my K or my SeaWorld, is I would have to turn around and drive back that way. So it would be in reverse. I would have to go in reverse because I'm basically past my equilibrium point Q, or my destination SeaWorld. So think of it like that when you're using like a GPS system. That's what Q is. When we study Q, Q allows us to predict where we are. It tells us where we are in relation to equilibrium. It is exactly the same form as Kc. It's the exact same expression. Products on top, reactants on the bottom. So you're not doing anything different. You're taking the products, coefficients become exponents. You're taking the reactants and putting them down there. And the coefficients become exponents. But it can be Q. The difference is with Q, it can be for any concentrations, it's not going to just say at equilibrium. In fact, the key word that they will often ask you is predict. They'll say predict which direction the reaction is going to go. They're asking you to predict. That's basically asking you Q, and they'll give you all the things for the equation. So they would give me an E, F, A, and a B if I had it. So here's an example. And then like my example where I was giving you, where I was like trying to drive 190 miles and I was 75. Here's the way it works. Whenever Q is less than K, the reaction has to keep going forward. Kind of like in my driving example, if we've gone 75 miles, we're not at SeaWorld. If we've gone only 150 miles, we're not at SeaWorld, because it's less than the 190 required to actually get there. That's when Q is less than K. The forward reaction will occur, so the reaction will keep going forward. If Q is greater than K, so remember after the third hour, I've driven 225 miles. The only way I can get to equilibrium is that the reverse reaction has to occur. The reaction has to go backwards or to the left. If Q and K are equal, it means the reaction is equilibrium. So the whole point of finding Q is to compare it to the K value to see what's going on. So if Q is less than K, we know the reaction will go forward. If Q is greater than K, we know the reaction goes backwards. And if Q and K are equal, we know the reaction's in equilibrium. So typically, if you look at a graph when we're doing kinetics problems, and the graphs all had all kinds of slopes to them, that means you're not reaching equilibrium yet, because we say we reach equilibrium when the line goes flat, right? So we get a flat slope right there. That's when we reach equilibrium. That's when K and Q are equal. Before then, you're either above or below equilibrium, because remember, equilibrium is an exact spot. So how do we do this? Well, basically, here's what we do. We look at a problem. If you notice, they'll tell me a couple things. They tell me my Kc is 0.21, and they're going to ask me which direction is the reaction going to progress. Is the reaction at equilibrium, or which direction is it going to go? Well, remember I had told you that Q and K are calculated the exact same way. This is like saying my C world is at 0.21. So then what I do, my first step in the problem is I am going to write an equilibrium expression. So here's the reaction is NO2, 2NO2, so it goes 2NO2 squared on the top, N2O4 on the bottom. The exact same thing we've been doing. Products on top, reactants on the bottom. That is a coefficient of 2, so it gets squared. The next thing, if you notice in the problem, is I will be given concentrations. They will give you concentrations for everything in the expression. So then basically what I'm doing is I'm going to take the 0.55, drop it in the top and square it, 0.12, drop it in the bottom, do a little mathematics, bam, and I get 2.5. That is my Q. My Q is 2.5. My K is 0.21. That's my C world. So at this point, I compare the two numbers. Well, my Q is larger than my K. And if that happens, the first thing you want to do when you're writing this up is compare the two. Obviously, my Q is greater than my K, which means I am past equilibrium. It's like in the driving example, if I was 225 miles out of Boca, that means I drove past SeaWorld and I have to go backwards. Then I state the reaction is not at equilibrium and will proceed from the right to the left in order to reach equilibrium. That's basically what you're doing in a Q problem. That's the whole point. So if we look, here's another example. If you look, I have an equation right there. The first thing I would do would be, okay, I have to write the equilibrium expression. So I'd say, okay, HI to the second goes on top, H2 and I2 on the bottom equals K or Q at this point, but in this case I'm trying to find Q, so it's the same, it's basically done the same way. And they say, okay, well my mixture has this, this, and this. Notice I have all three values. So all I'm going to do basically is I'm going to take this number for HI, I'm going to take that number and square it, put those two numbers on the bottom, multiply it, and calculate it. Well, here's the problem completed. If I plug it in, square the top, multiply the two on the bottom, I get 5.73. Remember, in each problem, they're going to tell you what the Kc is. Notice how my Kc, my C world at this point, is K is equal to 54. So my K is equal to 54. What is my Q? When I pop it into the equation and get the calculation, I get 5.73. So where am I at? Well, at this point, I am less than equal. I'm basically before equilibrium at this point. I've driven 150 miles and SeaWorld is like 190 miles. So the way the reaction is going to go to reach equilibrium to get there is going to go from the left to the right, or what we say forward. So how would you write it up chemistry style? You would say Q is less than Kc, therefore the system is not in equilibrium. It will basically go from the reactants to the products. You could say left to right, however you want to say it, forward, same thing, and that's how you would summarize it. So basically, whenever they have you do this in an equilibrium problem, they're asking you to predict which way the reaction is going to go. They'll give you your K, that's one tip off, and they'll give you all the concentrations of all the reactants and products. You pop them in, calculate a value, and compare the two numbers, and you have your Q. All right? Have a good weekend. I will see you on Monday.